What is up, Prealgebra? This is lesson 81. We're going to be talking about central angles and arcs. A central angle is what we're going to talk about first. A central angle is just an angle whose vertex is on the center of a circle. So just think about if you had an angle like that, where this vertex right here is on the center of a circle, then we call that a central angle because its vertex is on the center of a circle. Also, you should note that if you added up all the central angles, this one just has two, right? This one and this one. But if we had more central angles as well, like this one, and maybe also these two, so if I added up like 1, 2, 3, 4 central angles, if I added those all up, it would total to 360. Because, like if you think about it, if you started here and went all the way around, that's 360 degrees. So here, this is example 1. It says, draw a circle with central angle that divides the circle evenly into thirds, so into 3. So since we're dividing it into 3, we're going to take that 360 and divide by 3. And that gives us 120. So what I need to do is, here's the center. There's one side of it that's 0 degrees. So I need to go and draw 120 degrees. Now I don't have a protractor on here, but we could estimate. It's going to be right about here. And then do another one, which is going to go right about here. Not exactly perfect, but you get the idea. So this would be 120 degrees, 120 degrees, 120 degrees. So adding those up would give you the 360, and there I've divided it into 3 equal parts. Alright, for example 2, it says the court of a playground game is painted on the blacktop. The court is formed by a circle with 2 intersected diameters, forming 4 central angles. One of the central angles measures 50 degrees. Find the measure of the other angles. So that word diameters, I don't know if you realized whenever I said it, is an important word. Because remember, a diameter is a line that goes from side to side while passing through the center. Now, isn't that simple? So if we draw with a marker and not with a highlighter, like this, and like this, it may not be to scale, but 2 diameters, notice it's passing through the center right there. And it says that one of them is measured 50 degrees. Well, since these are what we call vertical angles, this one over here would also be 50 degrees. And then these two would be the same. This one up here, and this one down here. Those two would be the same. Well, notice, if this is a diameter, that these two would measure up to 180. So there's kind of 2 different ways we could do that. We could say 180 minus 50, that'd give me the measure of this one. Or I could say 360, that's the measure all the way around, minus the 2 50s. That'd give me the measure of these two together, and since it's the same, if I divide by 2, it'd give me that. So I'm going to go just with the 180 minus the 50, because this is 180, that one's 50, so if I subtract that, would give me the measure of this other one. So it's going to be 130 degrees. So the other 3 angles would be 130 degrees, 50 degrees, and 130 degrees. Alright, and I'm sure you're asking, hey, you said we're going to be talking about central angles and arcs. How come we've just been talking about central angles? Well, we're going to talk about arcs now. An arc is a portion of the circle intercepted by the central angle. So this arc is kind of just like a piece of the circumference. Now, technically here, we actually have 2 different arcs. We have this red one here, and we also have this blue one that goes this way around. And for any single angle, there's always 2 arcs. The smaller one, which we call the minor arc, and the bigger one, which we call the major arc. Okay? So if we wanted to name this red one, we would just say where it starts and ends, AB, and then we put an arc over it. So if you just have 2 letters and with an arc over it, we know we're talking about the minor arc. So the shortest route to get from A to B. Because, see, I could also get from A to B going this way. But since I just have the A and B, it's talking about the shortest route from A to B. If I want to talk about the blue one, the major arc, I would say I start at A, I pass through C, and I end at B. This is the major arc. And so if it has 3 letters, we know it's always talking about the long way around, the major arc. Okay. Also, something to think about here. Let's look at this. If I told you this was 90 degrees, then you would know that this portion here, that this angle, is 1/4 of the whole circle, because 90 is 1/4 of 360. Likewise, we would be able to say that this red piece of the circumference is 1/4 of the way all the way around. Okay, so make sure you remember your 2 circumference formulas as we move into the next one. The circumference is pi times d, so if we know the diameter, or you could say 2 pi r if we know the radius. So you need to know that here as we move into our next example. So it says, what is the measure of arc AD, so this one right here, in degrees? What fraction of the circumference is the arc intercepted by the angle ABC if the radius of the circle is 6 centimeters? What is the length of the arc in terms of pi? So something I guess I should have mentioned on the previous slide is whatever the measure of this angle is, we say the measure of this arc in degrees is the same as that. So we'd say 60 degrees. So that's our first answer, 60 degrees. It says what fraction of the circumference is intercepted by this. So first off, we have to, I guess, reduce it. The measure of that angle is 60. And then we divide that by 360, because that's the measure all the way around. If I reduce that, 6 goes into this 10 times, and 6 goes into that 60 times. And then 10 goes into both of those, this would be 1/6. The what fraction? 1/6. That's my next part. And then it says, if the radius is 6 centimeters, what is the length? So I actually want to know, how far is it from A to B if you were to measure along the edge of that circle? So what we can do is we're going to take that fraction that we just found, we're going to say 1/6, and multiply that by how far it is the whole way around. Right? If I knew how far it is the whole way around, then I take 1/6 of that, and that would be the measure of this arc. Well, the circumference, since we know the radius, is going to be 2 times pi times the radius, which is 6 centimeters. Okay, now watch out here. It says, what is the length of the arc in terms of pi? Whenever it says in terms of pi, that means pi is going to be in my answer, so I'm not going to multiply in the 3.14. So let's just go ahead and multiply the 2 and the 6 together. So this is going to be 1/6 times 12 pi centimeters. Now I can multiply the 1/6 times the 12, or what's 12 divided by 6 gives me 2 pi centimeters. So the length along here, if this is 6 centimeters, this is 2 pi centimeters. Alright, your homework is on page 547. You're going to do the practice sets, all the 81s, all the 80s, plus 9 more of your choice. Good luck, guys.